Hello everybody, welcome back. This is the third of 8 sessions for our Praxis tutorials. Session number 3 is one of the shorter ones. It'll only run about 37 minutes. And this is going to be some physics. So we're going to talk about the difference between vectors and scalars. We'll learn how to calculate speed, accelerations, distance, displacement, and we'll also talk a little bit about Newton's laws and friction. Happy studying. You're going to kind of have to think about some of the stuff we talked about in session 1 if you were with us. If you weren't with us in session 1, we'll come back to it, but we did talk about protons, neutrons, and electrons when we talked about ions, isotopes, and ions, and atoms. All right, I'm going to leave the poll open for a second and come back to this first question. So we had a tie between answer choices C and D, with the electrons being transferred from the fur to the rod and the electrons being transferred from the rod to the fur. So what I want you guys to think about is what's happening to the rod. Is the rod gaining a positive or a negative charge? And if you have your sound on, you can.
The rod's negative.
The rod is gaining a negative charge, so that means the rod must be picking up what? Which particle has a negative charge?
Electrons.
Electrons. So if you think about it that way, the answer is C. The electrons are transferred from the fur to the rod. If the rod is negative, then it picked up more negative charge from the electrons. Okay. This question is partially chemistry, partially physics, so this kind of goes into the electrostatic range of the physics side, but I wanted to see what we were thinking. I do have one more question, and if you have the poll open, you can see it. Right here, I see one vote has already been cast for it. Tiny bits of paper are attracted to a charged rubber rod as the result of which of the following? So it's similar to the first question, but not exactly the same. Give another minute. Hopefully the poll is still up on your screen. If not, you can add your answer to the chat box as well. You can give 30 more seconds. I see some thinking. And again, you can answer in the poll or in the chat, whichever way works better for you. So in my poll, I have people answering A, and let's look at the correct answer for this one. The answer for this question is actually C. So the key to this word, so if you looked at one of the Quizlets I sent out in the pre-work, the word induction was in there. And induction literally talks about polarizing something and how things pick up positive and negative charges. So for this one, A and B do not work because we don't know what charge the rubber rod has. We don't know if it's a positive or negative charge, so we can't assume the paper has either charge. Same thing down here, net positive charges don't really happen in induction, so it has to be C, and the only way you would really know that one is if you knew the definition of induction, which literally means like to pick up a charge from another charged particle. So if you get a second, or if you didn't have a second to, please make sure you check out the Quizlets. It was just some vocabulary terms that go with the physical science section. I'm gonna keep moving just to respect your time for tonight. It's already 7:11 and I don't want to take y'all too far past 8. I know everybody has things to do. Again, we're gonna start talking about the physics part of the test. So physical science is actually a course offered in CMS, and it's half physics, half chemistry. On the Praxis, the physical science part is half physics, half chemistry. It's the same thing. So in the physics portion of the exam, these are the major topics that they cover. So they talk about electricity and magnetism, which was very similar to the second question we had. They also talk about mechanics. So that's what we're going to focus on. We're going to focus on mechanics and dynamics today. And if we have time, I'll get into the waves part. If we don't have time, I will just kind of record the waves part on Screencast-O-Matic and send it out so people can kind of watch that on their own leisure, and then we can kind of come back to that. Remember, guys, that the Praxis is calculator free, which means anything in terms of like mathematical concepts, if they ask you a math-based problem, it's going to be something that you can solve with like pen and paper. It's not going to be a in-depth math-based equation for any of the sciences because you won't have a calculator. So when we talk about some of these things like speed and distance and acceleration, I'm going to give you some problems in the equations, but the numbers should be easy enough that you should be able to solve them without too much work. But that also means when they ask you questions about these, they are looking more to see if you understand the concept versus if you can plug numbers in and solve the equation, if that makes sense. So they want to know, do you know what speed is, not do you know how to calculate speed? Make sense? So that's why I'm going to kind of go through definitions here and talk about how these things are related. And again, we'll go through some practice problems. One last time, if we don't have time to get to waves or if the time is coming too short, I don't want to just squeeze it in there. So I'll just record it on Screencast and send it out probably tomorrow if we don't have time to get there. So we're going to briefly start talking about kinematics. In science, kinematics is the science of motion. So that means anytime you describe motion using words, diagrams, numbers, or graph, you are in kinematics, which is physics. Motion in physics is when you change your position relative to a reference point. So if I'm standing still and I move forward, if I'm standing where I'm at and I move someplace else, that is considered to be motion. The key definition or the key part to motion is that you have to change your position. If there is no change in position, there is no motion. So that's the key thing here. In kinematics, there are two different quantities that we're going to be dealing with. One is called a scalar, the other one is called a vector. Scalars in brief are described by a number. So if I tell you a car is moving 45 miles per hour, that is a scalar quantity. It's just a number. However, if I tell you a car is moving 45 miles per hour north, I have now created a vector. Vectors have numbers and directions. So if I tell you I'm walking 35 miles per hour east, which would be crazy fast for me to walk, I'm now giving you the whole vector. If it was just 35 miles per hour, that's a scalar. So when we're going to talk about a couple different scalar and vector quantities. For ease, I'm a very visual learner, so I made all the scalars green and all of our vectors orange to kind of hopefully help us keep them together. In physics, which is kind of nice, usually every scalar has a vector to go with it, so these usually go hand in hand. So I'm going to kind of teach the mirrors of each other to keep them, to hopefully make them make sense. The first scalar I want to talk about this evening is distance. So distance is just how much your object has moved. So how much ground you have covered during your motions. So in my little example problem, it says Shauna has walked 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. What is my total distance in that problem? And if you have your sound on, you can just shout it out to me if you know the answer. Oh, you guys are quiet tonight, huh? Oh, I saw some hands flashing. I'm sorry, I can only see 4 of you guys on my screen at a time, so I have to like scroll through.
10.
But I heard 10, I heard 12. Everybody is performing the same math, essentially. We're gonna add all these numbers up to get my total distance. So my total distance is just 12 meters. 4 plus 4 is 8, 8 plus 4 is 12. Right? Simple enough. So distance is the entire journey from start to end, however much ground you have moved, that is your distance. Remember, this has no direction, so it's just a scalar quantity. The vector that goes with this scalar is displacement. So distance is how far you've traveled. Displacement is how far you are from where you started. So it's important to note that distance and displacement can be the same, however, they are not always. For example, in this problem, we already said my distance is 12. But say, let me see if I can draw. Let me see if I can draw a little stick person. So say I start and end right there. I took that whole journey, did my 12 meters, but I end where I start. What is my displacement?
0.
0. If I start where I start, if I start where I start, my displacement is now 0. Right? Now, if I gave you a different problem, so say I started here where my little stick person is, but I ended here.
4 meters.
4 meters what? Remember, it's a vector.
East?
Yes. Yeah. So Brian just told us that my new displacement would be 4 meters east from where I originally started. Make sense?
Mhm.
But what is my distance still 12 in that problem?
Yes. Oh, wait.
Pretend that's not there.
Distance is still 12. No, wait. 6, 7, 8. I'm gonna.
8.
It's either 4 or 8. I'm gonna go with 4. Oh
Close.
no, 8.
Good job. So you will still keep adding up all of your quantities to get your total distance. But my displacement would be 4 meters east from where I started.
Mhm.
So again, if they give you problems on the math side, the math is going to be that simple. They're not going to give you too much more in depth because they really want you just to know the concept. So we've got our first scalar and vector, distance and displacement. The next one I want to talk about is speed. So speed is a scalar, which means it's only going to have a number. And that is literally just how fast something is moving. For those of you that may have to teach physics, physical science, chemistry, we do these as well. This is what we call a formula triangle. I am not a very good math student. I literally tell my chemistry kids, like, I can do chemistry math and basic physics math, and like, that's it. Don't ask me to do anything else. So we use these formula triangles to kind of help our students conceptualize the 3 different ways to organize this problem. So we tell them that if the letters are next to each other, that means multiply. If they're above, top and bottom, that means divide them. And they can use this triangle to rearrange it easily without them having to like move letters around and try to figure out how to solve for which variable, which tends to confuse them. You can use this simple triangle to solve for any of the variables. So say you wanted to solve for speed, which is the S. All you have to do is hide the variable that you're going to try to solve for. So if I want to find, speed, what's left over?
Distance and time.
Distance and time. So that means the formula for speed is equal to, distance divided by time. So if you want to find distance, so pretend your distance is gone, what's left?
Speed and time.
So that means the formula for distance is equal to speed times time, because they're next to each other. If I have any Delta friends in the room, that one's for you. Okay. Makes sense how to use the triangle?
Yep.
If you have any formula that has 3 variables, you can plug it into this type of triangle and it'll work the same way. So like in chemistry, we have to teach the kids Density, D equals M over V. So we teach them density is equal to mass over volume. If they want to find mass, it's just density times volume. So we teach them the same way with any 3-factor formula. Just a little tool if you ever want to use it for your kids. Now, when we talk about speed or scalar, we have that question again about my distance. So this one asked you, what is my speed? It says I walk this distance in 24 seconds. If we remember the triangle, okay, nothing's working. Here we go. Speed is distance over time. How would I quickly solve for this problem? What is my distance?
1/2 or something.
Yeah, because my distance is what?
12,
12 meters. And I'd walk that 12 meters in how many seconds?
24 seconds.
That means I am Speedy Gonzalez. 12 by 24 is the same thing as saying
1/2.
1/2. And in chemistry, we kind of don't really like fractions as much. So we say it's 0.5
Okay,
meters
0.5.
per second.
Ooh, per second, bet.
Yeah, so our unit is meters per second because we're dividing the M by the S. So it literally just becomes M over S for our unit. But again, easy numbers, not anything where you'd have to be like, I need my calculator, hopefully. Again, no direction because it's just a scalar. So the vector that's going to go with speed, and I'll come back to these in a second, just to make sure. The vector that goes with speed is velocity. Be careful here. The velocity formula is displacement over time, not distance over time. Because the velocity measures the rate at which you change your position. So remember, displacement is how far you are from where you started. Velocity is a measure of you changing your displacement, essentially. So key here, we just said that if you start and stop at the same place, your displacement is what? 0. I see people giving me goose eggs. If your displacement is 0, that means the velocity in that situation would also have to be
0.
0. If there is no displacement, there is no velocity. And that's where they like to kind of get people on some of these questions, is the difference, because they don't remember that the D here is displacement, not distance. Speed and distance, velocity and displacement. Those go together. Am I talking too fast? Does anybody need me to slow down?
You said D in density and B in velocity?
Speed and,
say that one more time.
Speed and distance.
Speed and
Yep. Unfortunately, in chemistry and physics, there's a bunch of D vectors that kind of like, you have density, displacement, distance, they all kind of get jumbled in. But on the Praxis, you do get a very small reference table. Let me see if you can see it. So you'll get a periodic table, and you'll get, it'll look like this, and I know you probably hard to see in my book version. But it literally says table of information, and it's got some of these formulas listed in there for you. So these aren't things that you necessarily have to memorize. But again, they're not so much concerned with if you can do the math. They want you to know, do you know what these are? Because you don't have a calculator.
I'm sorry, could you email that to us?
Mm-hmm.
Or is that too much?
No, I can. Okay. I'm gonna find a PDF. If not, I'll scan it when I go to work tomorrow.
Okay, perfect. Thank you.
You're welcome.
Did you say that if there was no velocity, there's no displacement?
If there's no displacement, there's no velocity.
Okay.
Because this D right here is displacement. So if this was 0 in a number on the bottom, if you divide anything to 0, the answer is still 0. So we don't really mess with negative integers too much there. Okay. We already answered that one. Last vector I want to talk about briefly is acceleration. Acceleration is the rate at which we change velocity. So velocity is the rate at which you change your displacement. Acceleration is how much your velocity is changing throughout the whole thing. I brought this one up too to kind of help you guys identify this triangle. In physics and chemistry, the triangle means delta, and delta means change. So if you see delta V over delta T, that means your change in velocity over your change in time. It's important to note that when you calculate the change in something, it's always the final minus the initial. So your final acceleration minus your initial velocity. Sorry, I should say velocity right there. It's a mistake. But delta, the triangle, is change. So another way they're going to get you, we already said if displacement is 0, what else has to be 0?
Velocity.
Velocity.
So if velocity is 0, that means acceleration would have to be
0.
0. Those would all have to go together because of the displacement part. Now, I'm going to give you guys a question. The answer is going to seem obvious at first, but there's one more piece of information. So I'm going to give it to you for a second. I'm going to give you 30 seconds to think and see if you can get it, but there's one more thing that you might need, okay? Here's our question.
How are we supposed to answer this?
You need something else. There's one more piece of information you will need to know. So I'm gonna give people like 10 more seconds to read that question through. And there's one more piece I'm gonna add on there for you, and that will make this question make a whole lot more sense. And I'm looking for one more example in here for you. Gotta find that example I had. Okay. So to answer this question, oh, I see an answer in my chat. Okay, I see someone saying 0. Any other guesses? Everybody's like, yeah, I don't really know right now. Okay.
I know it, but I don't want to say it because
Oh, were you in the session on the first
I
rotation?
think this is when I started. I couldn't remember, so.
Okay, so yeah, hold on to that for a second. Let's go through this real quick. To answer this question, there's one more piece of information that you need, and it's something called dynamics. Dynamics are the same thing as Newton's laws of motion. So to fully understand that question, you're going to have to take the concept of kinematics, the study of motion, and put it with this dynamic thing. Most of Newton's laws you have heard time and time again, so I'm not going to spend a whole bunch of time here drilling this into your head. It's like, do you have it? I'm just going to go through them quickly to make sure we understand. So first, let's start with Newton's first law of motion, which is called the law of inertia. So to think about the law of inertia, I want you guys to think about this hamster in the wheel. If my hamster stops running, what would happen? Or if the hamster stops running, what happens to the wheel? Does it keep going or does it stop?
It keeps going for a second and then it stops.
Why does it stop?
Because the hamster stops. Energy isn't pushing it.
Close. Very, very close. Thank you for talking. I was like, oh man, no one's gonna answer my question, hamster. This is the same reason. Anybody ever been in a car accident? Or been in like one of my little brothers is learning how to drive, and he's still at that phase where you're like constantly like this and you're being choked by the seatbelt. So the reason that happens to the hamster and the reason why it happens to you when you're like getting choked by the seatbelt and it hits that resistance point is because of the law of inertia. Inertia says an object at rest stays at rest, or an object in motion stays in motion unless a force is acted on it. So if this little hamster on the wheel was in a perfect vacuum and he stopped running, that wheel would still keep going, but it doesn't because we have all of these other outside forces that act on it. So it's not fully about energy, it's more about friction and forces. And we have this thing called gravity, which is a force, which will eventually slow everything down. So in our car example, if you're driving in a car and somebody suddenly slams on the brakes, your body is still traveling in that direction until something stops you, which is your seatbelt. That has to be a force that will act on you to put you at rest. Make sense?
Mm-hmm.
So that is the first law of inertia, which most people have heard, that in motion stays in motion, at rest stays at rest. But what most people kind of don't know is how these all tie together. So first is inertia. Second is actually an equation. The second law of Newton is F equals ma, force equals mass times acceleration. Now remember, in the first law, it says we stay at that state unless a force acts on us. To have a force, you also need mass and acceleration, so these go together. Another threefold triangle thing here for you. But what I really wanted to talk about in terms of this law is the different forces. Okay. Here we go. Can y'all see me? Is it moving now?
Mm-hmm.
Okay, I thought it had paused for a second. So again, I'm not going to focus too much on the equation F equals ma. I really want to talk about these forces quickly because this is where they try to get you. So in physics, a force is anything that has some oomph to it. It can be a push or it can be a pull. There are a couple major forces to know, and the first one is friction. So when you have two objects in contact with one another, there is a frictional force between them. The two different types of friction are static and sliding. So if you have two objects that are not moving, they're kind of stuck there in limbo, that is static friction. If you have two objects that are sliding past one another, you now have rolling friction. But if two things are in direct contact, that is friction. Okay. We always make our kids like rub our hands together and you hear all like the dry hands in the classroom. It's kind of funny at the same time. All of that. We're like, oh, that's friction because you're ashy. So if you want to teach physics. So again, friction is two forces sliding past one another. Next force to know is air resistance. So air resistance is a type of friction, but that's due to air. So this is an object in the air surrounding it. They have air resistance. Air resistance first directly depends on the size, shape, and speed of an object. So the smaller and more aerodynamic you are, the less air resistance. So think a bullet, very small aerodynamic, little to no air resistance. The bigger you are, the more resistance you have. So this is what they are playing on when they design cars. That's why they left the box method of a car and like have these little sleek things where like the old commercials they had with like the air tunnel of the car and they show you how the air goes over top. They're showing you that they're less resistant to wind drag. But the other thing that really affects air resistance is gravity. So we have this thing called terminal velocity. That occurs when the force of gravity is equal to the air resistance. So if I have a ball and I throw it straight up in the air, right before the ball comes back down, it's going to reach its terminal velocity. So that means the gravity is going to be pulling at its maximum, but the air resistance is holding it up right before it comes back down. Now, most things when they fall down will reach a point where the air resistance will be null and void. So if you've ever heard the example about like the ping pong and the bowling ball, if you throw them off the building, which one will hit the ground first? And technically they'll hit the ground at about the same time. That means both of them will reach a point of terminal velocity where the air resistance will be canceled out and everything will fall at the same rate, which is the rate of gravity. Anybody know what the rate of gravity is here on Earth? It's an important number. 9.8 meters per second squared. In case anybody didn't hear it. Gravity is 9.8 meters per second squared. So the last force that I want to talk about is gravity. A couple things to remember about gravity. Gravity is dependent upon mass. So the more mass, the more gravity. That's why the pull of gravity on Earth is stronger than the pull of gravity on the moon. The moon is less massive than the Earth. So gravity and mass are directly dependent. Distance also affects gravity. So the more distance you have, the less gravity between the objects. Okay. Now, if we take those concepts and try to apply it back to that question, this one again, you have to consider the dynamics piece and you have to consider motion. So it says I throw an object vertically upward, which means I take a ball and I throw it. What is my acceleration going to be right at the top of my throw? So think about it. If the acceleration was 0, what does that also mean about the displacement?
It's 0.
It would be 0. Is my displacement 0 in this equation? Is the ball back in my hand?
No.
No. So that means A, if we do process of elimination, A is out of there. Because right now the ball is still, it's as far away from me as possible. Okay. Now when you're at the peak of my throw, is the ball gonna go up or down?
Down.
Like if it's as far as I can throw it up, where is it about to come?
Down.
It's about to come back down, right? So if it's at, it says it's at the top of its path, which means it's literally at the point where it's about to plummet. So that means the force of gravity can't be pulling up because the ball is at the top of its path. So B is out of the equation. So now we're down to C and D. Which one do we think we can get rid of? I see people pointing down. So are we thinking the answer is C?
C.
I see some nods, I see some yeses, and I see a D. Oh, that was to me privately, sorry. I see a D and I see a C in the chat, and the answer here is C. Can't be D because we know 0 is not a possibility. So A and D kind of get thrown out the window. It's 9.8 meters per second down because the ball is at the top of its path. So it literally is about to be pulled back down to the earth because it cannot accelerate up any further. So the answer here is 9.8 meters per second down. So, excuse me, that was a lot of explanation to get to one answer. But these are the type of questions they like to ask you in terms of physics. They don't want the formula. They want to know, can you combine 2 different trains of thoughts or concepts to answer one question? Make sense?
Mm-hmm.
Okay. So I want to give us another practice problem. But for this one, what I'm going to do is split us up into 3 smaller groups for about 2 minutes. I'm going to put a link in the chat with this question on it so that you can pull it back up and refer back to it. But I just want you guys to talk it out. See if you can figure out what the answer should be, and then I'll pull us all back for whole group and see if we can come to a conclusion. Okay. So guys, what are we thinking? What were some, I heard some good explanations and some good train of thought. What do we think the answer is?
D.
I'm going with B.
Okay, I hear some D's and I hear some B's. What else?
We thought A.
Okay. Let me give you a hint. And the hint lies in Newton's 3rd law. Does anybody know what Newton's 3rd says?
Gravity.
Every action, there's a reaction or something like that.
For every action, there is an equal and opposite reaction. So when we think about Newton's 3rd law, if we have a tractor pulling the wagon full of hay, the mass of the hay wagon and the tractor is negligent because it's talking about a very specific moment. And in the first session, we had like a whole discussion about this one instant. It's talking about the moment the tractor accelerates, what is the force on the wagon? According to Newton's third, the answer should be what?
B.
So look at it like this picture right here. Right before the car moves, the trailer and the car are at equal and opposite reaction. Things start to move because the forces change, but that one instance before anything starts to slip, everything is at equal and opposite. So that's the instance that it's talking about in that problem. And so that's why I was saying don't second guess yourself, because a lot of you guys started with B and then you were like, wait a minute, let's start thinking about the maths. Don't second guess. Go with your gut on some of these, because this one
Okay,
is B.
So can I try to explain D and you prove me wrong?
Yes.
All right, so I'm saying D because it's asking, if it's saying, now I understand why it's B. So don't get me wrong, I understand why it's B. But I changed it to D because I started looking and I was like, okay, D makes sense. So let me go with my thought process. I want you to prove me wrong. All right, so it says the tractor is pulling a wagon full of hay. The mass of the hay wagon is 2 times the mass of the tractor. When the tractor accelerates forward, the force that the wagon exerts on the tractor is, okay, so if the tractor was not accelerating, the force from the hay would be more, right?
If the tractor was not accelerating, then the force
Right. Of the hay would be more than what the tractor is doing at that moment, right?
Yeah, so like if the tractor was on and was not able to move, then the wagon with the hay would have more force than the tractor.
Right. So once you crank the tractor up and you start moving, then the tractor has to build up enough force to start moving it, which I agree is in the negative until it gets to 0. Then when it gets to 0, boom, we're equal. Right? Am I thinking too deep? I'm thinking too deep. All right, I'm done.
No. So here's the one word I want to highlight for you and why it can't be 0. Hold on, I'm trying to find my highlighter. I can't find it. But the key word is accelerate, right? So remember, in order to
negatively accelerate.
Right. And in order to have acceleration, you have to have displacement. If you have displacement, then 0 can't be a thing. So that would take D out of the equation. Cool. I love your train of thought though. So what you're thinking about is like net forces and like who cancels out what, and when we have Newtons, which is a great train of thought.
Too
Too
deep.
I told you, y'all science, us science.
That's why I was like, why'd you change your answer? Because you had it.
You guys are
Yes,
great.
I appreciate that. Thank you.
No problem. It was hard for me to explain, but you had it.
Me every time. So welcome to my word, trying to teach physics to 16-year-olds who don't care. They're like, Miss Fields, I don't care. And I'm like, okay, well, we try. How's everybody doing?